So we'll start off with Girish from Neeve Research, who will enlighten us. Girish?
Hey, brother, do you still believe in one another? Hey, sister.
Good morning, everyone. My name is Girish Mutreja. I am from Neeve Research. And what I'm about to talk about today is effectively about the X platform. So the X platform is a platform that has been sort of being incubated and being built out for the past almost a decade. And we're in the process of taking it out to market right now. So I just wanted to talk about the X platform and the key innovations that have gone into the platform for the next few minutes. So what is the X platform? So essentially, the X platform is a platform to author and run Java applications to operate at in-memory speeds. What does that mean? The idea is that if we really want to harness the power of in-memory computing, we should be able to operate at speeds that memory allows you, which is not milliseconds. It is actually microseconds. It is nanoseconds. So the idea is that when you're building an application that leverages memory, the X platform allows you to operate at that memory speed, but since it's designed for transactional applications, it is designed for applications that cannot afford loss. The idea is to be able to operate at that memory speed without compromising on durability, consistency, which are two key aspects of any kind of transaction processing, allow you to be able to scale in a horizontal fashion, but most importantly, to allow you to realize the promise of in-memory computing, which is simplicity. So how do we do that? The basic premise behind the X platform is that existing application architectures and implementation techniques cannot allow you to harness the full power of in-memory computing. It is because the existing application architectures are based on the technologies that existed around which they were built. Databases, synchronous replication, the ability to be able to harness memory in a partitioned fashion. There are inherent limitations to the way applications are architected that prevent you from being able to realize the full potential of in-memory computing. So therefore, in order to really tap into in-memory systems and in-memory computing, you need to rethink architecture and rethink some of the implementation techniques that have gone into building your applications. What are those? So the X platform has essentially, over the years, done a few things. One is established a new way by which you actually build applications. It's a new application architectural pattern that allows you to truly realize the full potential of in-memory computing. Secondly, it implements certain facilities that allow you to be able to tap into the full power of Java as a language that you actually use to program your business logic. Remove all infrastructural footprint, all non-functional aspects from your Java code. Your Java code should be operating completely in memory, as if memory is the new disk, as if it's durable. That is what the full potential of Java is. We spend about 50 to 60% of our time nowadays writing non-functional code. We shouldn't. We should be writing just business logic. That's what Java is for. That's what platforms should enable. That's the second thing that the X platform has brought to bear. Third, there are certain facilities that you actually have to put in place to harness the speed of memory. You cannot do synchronous replication. You've got to go asynchronous. You've got to go pipeline. You've got to go to microseconds from milliseconds. So these three core aspects have been actually put in place by the X platform in order to take it to the next level. Certain elements of features that went into the X platform in order to make this happen. The capability to do what is called data striping and message routing. The marriage between data management systems and messaging systems. Messaging systems do movement of data really quickly. Data management systems do management of data at rest really well. Marry the two rather than actually try to do both of them using one technology. The second, use application state purely as Java objects. No non-functional footprint in the Java in your application code. Full support for the Java data model. There is no reason to actually work with a subset of the data model. Why only maps? Why only lists? Work with the entire set of collections that Java gives you, so that when people program in Java, they just program in Java. They don't care about the fact that I have another tier in which I have to store data. The ability to be able to do transaction pipelining and multi-agency. There is a whole concept about in-memory management of information in a transactional way that allows you to be able to do pipelining. No synchronous replication anymore. No blocking of threads when you're actually doing transactions. Everything is completely pipelined, allowing massive amounts of throughput. Single-threaded business logic, make life simple. Concurrency comes at a cost. It flushes caches. It doesn't allow you to be able to scale beyond a certain point. I mean, locks have to be managed. Complexity comes into play. Remove all of that. Single-threaded business logic, and then a few very, very advanced implementations to do zero intertier transformations, no buffer copies all the way from networks all the way to the business logic, transparent to the business user. Nobody knows about the fact that from the network to the business logic, there is actually zero data copies that are happening. Allows you to go down to microsecond level latencies. And finally, the platform is zero garbage, no spikes. You can get a 100% flat curve when it comes to the performance of the system. There are zero spikes. You do not need to do actually anything special for that. What does that actually bring you? It brings you durability, speed, consistency, scalability. All of the non-functional aspects that you require in an application completely free, and in the extreme, microseconds, nanoseconds, not milliseconds anymore. So in order to kind of just illustrate the power of the application, we decided to write an application. And truth be told, this application was picked up by a couple of Neeve engineers. They wrote this in one night. On Sunday night, they wrote this application. The idea was, I have a mobile vehicle pool, and I want to actually track all the events coming in from the mobile vehicle pool in order to decide things like whether they are geofenced. If not geofenced, send out notifications that they're out of their particular area, or they're braking too fast, or certain things about that particular, those vehicles that need to be monitored. We wrote up the application that essentially is a set of location event processors using X, and wrote some intelligent rule execution using Java on that, and basically spit out inferences and decisions, which are very minor. What is the result? First of all, simplicity. This is what the code looks like in the X platform. There is absolutely no infrastructural footprint. No non-functional code. This is 100% pure Java. It has Java code. Its business logic can be read in a way that you're not actually distracted by any of the non-functional aspects. What does that bring you? It brings you simplicity. It brings you maintainability. It brings you the capability of testing this in a modular fashion. Slap this on top of the X platform and see what it can do. This is what it can do. Effectively, this particular application, we pumped it as hard as we could. On standard machines, it ran at the rate of approximately 400,000 transactions a second, fully fault tolerant, no data loss, will survive all sorts of failures. The response times for any notifications that were going out were sub 2 milliseconds at 400,000 transactions a second. And I'm telling you, it's absolutely fault tolerant. There is no data loss. You pull a plug, you take the network out, you can basically take a machine out, take the process out, it will continue to run at 400,000 transactions a second at 1.7 milliseconds latency. All of this, because of the capabilities that are there in the X platform in terms of the way it does pipelining, the way it manages cores, the way it puts actually its code in a compact manner in L1, L2, L3 caches, you will end up running the entire thing. Less than 100 lines of code, but more importantly, one CPU socket. 400,000 transactions a second running on one CPU socket, 4 cores. That's basically what it takes in order to run this particular application, and all of it on stock hardware. There is no special hardware that is needed in order to run this particular application. So to summarize, the X platform is essentially a platform that has been incubated over the past several years with the intent of harnessing the full power of memory, bringing simplicity to you as a developer so you can focus exclusively on business logic and perform at speeds that to a certain extent have not been heard so before. Hundreds of thousands of transactions a second, millions of transactions a second when you start striping and partitioning your data at microseconds to sub-100 microseconds latencies when you're actually working with ultra-low latency applications. Thank you very much.